Section 3.6, direct variation. So here's some vocabulary about this section. Direct variation is an equation that looks like this. Y equals A times X. The constant of variation is that A value, and Y is said to vary directly with X. And it doesn't just have to be with Y's and X's. The dependent variable, which is typically represented with the letter Y, is said to vary directly with the independent variable, which is typically represented with X. But again, it doesn't have to be with Y's and X's. You can use other variables that represent other quantities. An example of a direct variation equation would be Y equals 6x. The 6 would be your constant of variation. An example that is not a constant variation equation would be Y equals x plus 6. The constant of variation needs to be multiplying the x value. So again, Y equals x plus 6 is not an example of direct variation. You can tell if something is in direct variation form if the Y is by itself and there is a constant term multiplying the x value, which we'll see in the next examples. Example number 1, tell whether the equation represents direct variation. If so, identify the constant of variation. So again, you can identify an equation as direct variation if the Y is by itself and there is a number in front of the x multiplying the x. So the first one is negative x plus y equals 1. To get y by itself there, I would add x to both sides. 1 plus x is 1 plus x. So therefore, y equals 1 plus x. There is not a number in front of the x that is multiplying the x. This time, x is being added with the 1. So therefore, this is not a direct variation equation. Number 2, 2x plus y equals 0. To get y by itself here, I would subtract 2x from both sides. Since 0 minus 2x is negative 2x, I end up with y equals negative 2x. Here I do have a number in front of the x that is multiplying the x. So in this case, this is a direct variation equation, and the constant of variation would have been negative 2. The last one, to get y by itself, I would subtract 4x from both sides. 0 minus 4x is negative 4x. And if I divide both sides by negative 5, a negative divided by a negative is a positive, so I would end up with 4/5 x. Now that y is by itself and there is a number in front of x multiplying the x, this is a direct variation equation, and the constant of variation would be 4/5. Direct variation graphs. Notice that y equals ax is really an equation in slope-intercept form, where m is that a value and b would just be 0 since there is no number there. Remember that a value is the constant of variation. So we can easily graph these equations using the a number as the slope, like rise over run, and starting at the origin since the y-intercept is 0, which you will see in the next examples. Example number 2, graph the direct variation equation y equals 2/5 x. So remember, that's really just in slope-intercept form. So the slope would be 2/5 since that's the number in front of x, and since there is no y-intercept, it would be 0. Remember, you plot the y-intercept first on the y-axis, and then starting from that point, you use the slope as rise over run in order to find the other points and graph your line. So in this case, I'm going to start at 0, which is the origin, and I'm going to go up to and over 5. So you can see there I started at the 0, I went up to and over 5, and now I'll just connect those 2 points. And there you have the graph of the direct variation equation y equals 2/5 x. Example number 3, the graph of a direct variation equation is shown. Part A, write the direct variation equation. Now remember, direct variation is basically just a slope-intercept form equation. So what we just need to find is the y-intercept and the slope. So first, you can see that the y-intercept is at 0. The y-intercept for a direct variation equation is always going to be 0. Therefore, all you're left to find is the m, the slope. So they picked out 2 points for us, so we're just going to count rise over run. So I'm counting up 1, 2, 3, and over 2. So the slope would be 3 over 2. And again, the y-intercept of every direct variation equation is going to be 0. So our equation would be y equals 3 over 2x. Part B says find the value of y when x equals 14. So all we're going to do is take this x equals 14 and substitute that value in for the x in our direct variation equation we found in Part A. So we would have y equals 3 over 2, which remember is the same thing as 1.5 times 14. Therefore, we would have y equals 21 as our final answer. So again, y would equal 21 when x equals 14 if our direct variation equation was y equals 3 over 2x. This next graphic is just a screenshot that I took from your textbook that talks about the properties of graphs of direct variation equations. As we stated in the last slide, the y-intercept for every direct variation equation is 0, since it's always just y equals the a value, which represents the slope, times x plus nothing. There's nothing after your y equals a times x for there to be a y-intercept. Therefore, all you have to worry about is your a value, which is your slope. If your a value is greater than 0, like in the first picture, your graph will go uphill. If your a value is less than 0 in the second picture, your graph will go downhill. And again, every direct variation equation should go through the origin since your y-intercept is 0. Example number 4, an object that weighs 100 pounds on Earth would weigh just 6 pounds on Pluto. Assume the weight P on Pluto varies directly with weight E on Earth. Since P varies directly with E, that would mean that P is your dependent variable and E is your independent variable. That means our equation would be P equals the constant of variation times E. Therefore, for the first part where it says write a direct variation equation that relates P and E, our equation will look like P equals the constant of variation times E. We know that an object weighs 100 pounds on Earth when it would weigh just 6 pounds on Pluto. So I'm going to put 6 in for P and 100 in for E to now solve for the constant of variation A. So I would just simply divide both sides by 100. So 6 divided by 100 is 0.06. So therefore my direct variation equation would be P equals 0.06 times E. So I just had to use the given information to be able to solve for the constant of variation. Now using that equation, the next question is, what would a boulder weighing 750 pounds on Earth weigh on Pluto? So again, we're going to take our equation that we found in the first part, P equals 0.06 times E, and I'm going to substitute this 750 in for E since that's the weight on Earth. So I'd have P equals 0.06 times 750, which is equal to 45. And the label would be pounds, so it'd be 45 pounds on Pluto. So if something weighs 750 pounds on Earth, it would weigh 45 pounds on Pluto, since the gravitational pull from the sun is less on Pluto than it is on Earth, since Pluto is a lot further from the sun than the Earth is. Example number 5. The table shows the cost of buying used DVDs at a music store. So the number of DVDs is in the left column, and the cost is in the right column. Part A says, explain why C varies directly with D. Let's first identify the independent and dependent variable. In this case, the number of DVDs bought determines the total cost that you pay. So the number of DVDs is your independent variable, and the cost is your dependent variable. And now let's talk about how you test a table of values to see if the dependent variable varies directly with the independent variable. Again, to test a table of values to see if the dependent variable, which is usually the y value, varies directly with the independent variable, which is usually the x value, check the ratio of the dependent values over the independent values. So basically you're just going to take your dependent variable divided by your independent variable and see if you get a constant value. This is because the constant of variation equation, we have y equals a times x. So if I solve for a, I would basically just divide by x. So all of your constant of variations will be equal to y divided by x. So again, all we're going to take is our dependent variable values and divide by the independent variable values to see if we get a constant rate. If I do that, if I take 25.77 from our first set of numbers divided by 3, the independent variable, I get 859. If I take the next set, 51.54, divided by 6, I get 8.59. If I take 77.31 divided by 9, I get 8.59. Since I got the same number each time, 859, I can conclude that this is a direct variation equation. If I didn't get the same value every time, it would not be a direct variation equation or situation. Therefore, for part B, write a direct variation equation that relates D and C. Since I got 859 every time, that was my A value, because remember, if I take the dependent variable divided by the independent variable, that is equal to your constant of variation as we saw up here. So again, the A value is 859. So my direct variation equation would be C, in this case, since it is our dependent variable, equals 859 times D, which was our independent variable. And again, that is our direct variation equation. That's it for this section. Make sure you write down any questions that you have so we can cover it in class before we move on, and we'll see you then.